Welcome to the 4th Gradle Summit here in Palo Alto. We are excited that you are all here, and so our mission is to make you successful in efficiently shipping software. And we made tremendous progress, and that's what we want to talk about. And we have so much to talk about that I can already announce that we will go over time. And I'm serious about that. So we probably will go into the break for 5 to 10 minutes, but it's worth it. The Gradle build tool is the most used build system in the world. It has 2 million downloads per month. It also has an amazing community that heavily contributes, particularly via external plugins. We have now more than 800 community plugins in the portal, and so the Gradle build tool is very, very strong, massive momentum, and a lot of new features from us and from the community are being added to it almost every day. So let's start with what is new and noteworthy regarding the Gradle build tool, and this is a lot. So at the last summit, we showed you the first version of Buildship, our Gradle plugin for Eclipse. And this is a serious project, right? Tons of features have been added in the last 12 months, and I quickly want to talk about those. So the Gradle dependency graph is now always mapped correctly to the Eclipse transitive dependency graph, especially when you have version conflicts. One of the highlights of Buildship is that you can execute tests from the IDE via Gradle, right? Thus making your test execution a much richer experience because Gradle you can drive it via Gradle. And you can now do this per test method, per test, and not just for all tests. So you have the full user experience that you have when you run your tests via the IDE. This is now possible when you run them via Gradle. We had massive performance improvements for importing and syncing projects up to 2 orders of magnitude. So that's very exciting, and there's a richer UI and tons of other improvements, right? Improved WTP support, more metadata from Gradle is used to fully configure the project out of the box. And what is very exciting as an upcoming feature with Buildship 2.0 is Composite Build support. So it will be very convenient to work on multiple repositories at the same time from within the IDE. And we will talk more about composite builds in general a little bit later during this keynote. What is important to understand, Buildship not just improves the Eclipse experience, it is our reference implementation for IDE support. It triggers many improvements in the tooling API, which makes any Gradle IDE integration better, including IntelliJ and Android Studio. So don't miss the Buildship presentation. No, that's not the Buildship presentation. I just saw it. Okay, perfect. Excellent. I'm glad. So Friday, 1:15 p.m. I just want to quickly mention continuous mode. I think it's one of the most underused features in Gradle, right? The Gradle continuous mode allows you to run any task continuously, like a continuous local build server. And we have added capabilities, for example, that while a build is running, and you do some further changes to your input, they are queued up so that when this build is finished, the next build is immediately triggered. I don't know any other build system with such a capability. So if you are not using continuous mode, have a deep look at it. It can help in so many ways. Yesterday, we have released Gradle 3.0 Milestone 2. For those who remember Gradle 1.0, 7 more milestones to go. No, those were special times. There might be 1 or 2 more milestones. And after that, there will be a release candidate. 3.0 is a very major release. So let's talk about the new features. For those who are not aware, let me quickly say something about the Gradle daemon. The Gradle daemon is a local Gradle build server that is warmed up and caches a lot of the state of a build. So builds can be executed much faster that way. It is foundational for responsive Gradle experience. When you use Gradle via the IDE/tooling API, the daemon is always enabled. When you use Gradle via the command line, including CI, it is disabled by default. At least that was the situation until 3.0, right? So there are certain issues, right, we have with the daemon, right? One issue is many people don't enable the daemon, and then when they run a build from the command line, they are unhappy that their build is slow. They don't enable it because the threshold for setting this property, although it is very simple, seems to be too high. We have to accept that this is the user behavior. So to provide those group of people a responsive Gradle experience, we have to enable it by default to get rid of those treats. Oh, Gradle is so slow today. The daemon can also be corrupted by leaky extensions. So for example, when you do a non-forked compile with leaky annotation processors or apply leaky plugins, in such cases, Gradle stops working. This is not good. And on top of that, it is very hard for a developer to figure out what is going on when this is happening. So the problems, when there are problems with the daemon, they are opaque. There are also some open issues and bugs that have been related to Windows. So there were reasons why we didn't switch it on by default, but we have worked very hard on improving the daemon reliability and the daemon user experience. And Eric will show you some of that work.
Right. So just in case you're not familiar with the Gradle daemon, I want to allow it to introduce itself to you. What I have here is the Mockito project, a real project, and the pane on the right here is a build running compiled Java with the daemon, and the build on the left here is not running the daemon. And you can see how much faster running with the daemon is. And just on this first build, all right, so I'm excited to share with you some of the things that will be enabled in Gradle 3.0. As Hans said, I'm happy to announce that it's enabled by default. We've made it resource aware, so the daemon is now aware of its own JVM memory, garbage collector activity, other daemons, and overall system memory. And it can take action if system memory is constrained or GC activity is too high. We've made it much more robust. We want everyone to be able to use the daemon. And so we've squashed a whole lot of bugs, especially on Windows, with jar locking and so forth, so that we have no excuse. It should work exactly the same as without a daemon. Finally, we've added a few things to make the user experience a little bit better, a little bit more visible, and a little bit more accessible. For example, in 3.0 milestone 2, we've added Gradle status. And what this does is it allows you to see the status of your running daemons. Just simple stuff for right now, whether the process ID, the version, and its status. So it just tells you, hey, I'm busy, or I'm idle. And this is all available in 3.0 milestone 2. There's much more to come, but I hope that you guys will give it a try and give us some feedback so that we can make it solid for everyone, because we want everyone to use the daemon.
Yeah, thanks. And if you want to learn more about this work, there's a presentation on that on Friday. Again, a lot of engineering went into that, so it will be super interesting to get an in-detailed introduction into that work. Okay. Next feature. We introduced new mechanisms for using Gradle plugins a while back. And those mechanisms were incubating until recently, so we now added the missing features to make it production ready. That is the current we now call it the old way to apply Gradle plugins, right? And on top you see the new way. The syntax is much more concise. It saves you tons of boilerplate code. It makes it as easy to apply an external plugin as it is to apply a core plugin. And it will also give us the opportunity in the future to create a much smaller Gradle distribution. So for many core plugins, the reason why we added them to the distribution is to make it convenient to apply them for our users. And with the new plugin system, this is no longer necessary. Until recently, it was not possible to use the new plugin system with custom repositories. You have to keep in mind that with the new syntax, you apply a plugin. You do not specify a library. So it's not completely trivial, right, to connect them with custom repositories. In any case, this is now possible. We partnered with Netflix to do this work, and they have many Gradle plugins, and they want to make it very convenient for their developers to use those plugins, but they obviously want their private infrastructure to host their internal Netflix plugins, and now every organization can do that. Finally, what you also couldn't do with the new mechanism until Gradle 3.0 milestone 2 was to do cross-configuration, so that you inject from a root project plugins into sub-project. That is now working as well. So this is a foundational feature, right? The new plugin system is much more than syntactic sugar. It is a complete new mechanism for using plugins. And it will allow us in the future to provide better class path isolation and, very important, to provide very efficient parallel configuration of your build. There's a talk on the new plugin mechanism this afternoon, so if you're interested, I highly recommend that. So next feature. Many of you have heard about it. You can now write Gradle builds with Kotlin. We have released the first milestone of Gradle Kotlin Support a little bit more than a month ago, and yesterday we have released the second milestone. This is one of the highlights of the year, and even beyond that. So, hey Chris and Rodrigo, let's rock and roll.
Okay, so as Hans just mentioned, we just released yesterday version 0.20, so it's a pre-release of the support for writing Gradle build scripts in Kotlin. And as you can see in the updates there's a bunch of new stuff in the box. How many people have seen this work so far? Saw, say, the 0.10 or the milestone 1 release? Yeah, a few people, right? But it's new to most everybody because it's brand new to us too. There's a lot in the box, so we want to show you a few things as we go. And the best way to do it is to do it live coding, right? Because this is all about auto-completion and things like that. So imagine that Rodrigo and I work together in some enterprise, and we've just gotten a new requirement for our build automation needs, right? We need to write a very sophisticated greeting task, right? And so the first thing that you see here is this is just a normal Gradle project, like any other that you would import into IDEA or Eclipse. The Gradle wrappers there and so on. There's just one thing different. This build.gradle has .kts at the end, right? That stands for Kotlin script. But it's still just Gradle, right? So the fundamental abstraction with making Gradle do anything is a task, right? So we should be able to start typing task, get an auto-completion context, decide what we want to name the task. We'll call it greet. Open up a block, just like a closure that you're familiar with. And then what's available, right? What can you do with a task? Oh, we want to do last, right? That's the typical thing that you do with a Gradle task. And we probably want to print something out to the console. Our very sophisticated greeting, right? Hello world. Okay, so with that, we should be able to then run the task like you usually would. Execute a Gradle task, greet, and hello world, right? Yay.
Nice.
Okay. So we're done here, right?
Yeah, I'm a bit afraid that we wrote like 5 lines of code and we got something wrong already, like we're missing a comma there. So I'm afraid we're not really experts on the greeting domain.
That's probably true. Yeah, well, actually, that reminds me, my friend Bob, he works for this hot new startup called Example. And I heard they're really disrupting the greeting industry. I got early access to a build of their new library, their new open source library called Greeter. And yeah, I uploaded it to one of our repositories. It's a Maven repository. And the URL is repo.gradle.org. That's our Artifactory server. Gradle demo, right? That's where I put it, since this is a demo. And yeah, then we need to put the dependency, the actual library, on the class path. So we just want to reuse this greeting library instead of inventing the wheel ourselves, which we obviously did badly, right?
So add it to the class path, you said?
Right, so add it to the build script class path. And the gav is org.example greeter and 0.1.1.
Okay.
Okay, so you might have noticed IDEA was just thinking there for a second when Rodrigo finished typing that. And what it was doing when it was thinking was actually resolving that and putting it on the build script class path so that it's available for us right now. So the way the library works is there's this greeter type, a greeter class that you can instantiate, and then you can access its greeting, which has a default value, and we can just print that out. Software reuse at its finest. Right? And notice the import is up there as well, right? Yeah, okay, greet and hello world with a comma. Excellent.
Yeah.
Yay. Okay, so we're done now, right?
Yeah, Bob certainly knows the greeting domain much better.
They've got
than
that
us.
domain on lockdown, yeah.
Amazing. Yeah, I'm thinking, I mean, so many people could benefit from this work we just did, right? So maybe we could package this as a plugin.
Ah, into a Gradle plugin, yeah. Well, actually, that reminds me that Bob and his team were thinking ahead, right? They knew that if they wanted to get this into the hands of lots of developers, they'd have to create a Gradle plugin. And so there actually is one. It's org example greeter-plugin. And it's 010. Yeah. And so once that's on the class path, we should be able to apply it. And it's a greeter plugin.
Very good.
So you can apply by ID, but you can also, you've always been able to apply by type in Gradle as well. And so we're applying by type here so that we can like navigate to the source and see what this plugin actually does. It looks like it has an extension, a plugin extension that you can use to configure the plugin. And it also adds a task called greet, which was what we just did ourselves. But now we can just rely on the plugin's implementation to do it.
Mm-hmm.
Okay, so we delete our dependency on the library. Now we only depend on the plugin. And we run again. And same behavior, but now we didn't have to write almost anything ourselves, right?
Yeah.
Okay, so surely we must be done now.
You know what?
What?
I know some people like hello. I'm more of a hire myself.
Okay.
And many people, you know, have different preference. So maybe we should allow for customization here. Maybe.
Okay.
Yeah.
Okay, well, it's just a Gradle build, right? And Gradle's always had the ability to externalize properties. You know, you might put it in a Gradle.properties file. You might add a -p flag at the command line. So all of that still works as it always would, but how would we access it in a Kotlin build, right? Well, this greeting plugin has an extension like we talked about. So we could just customize it, still hard coding this hi. And it works like you'd expect. But like Rodrigo was saying, like maybe we should make it available to, you know, the different build users to specify which sort of salutation, which sort of greeting they want to say. And so this is something, another new thing with Kotlin support, is that we're actually declaring a property, a Kotlin property, in the build script, your favorite greeting. So that's going to be the name of a property that you supply, whether in again, a Gradle.properties file or a -p flag. And that property is going to be delegated to the project. So it'll actually, under the covers, call Gradle's project.findProperty to resolve this. But along the way, like, okay, we say greeting equals favorite greeting, and we get this error. And the error is, well, Gradle properties can be anything. They aren't just necessarily strings, but our library, our plugin, takes a string. So already Kotlin is telling us, like, hey, something's not safe here, right? So we need to actually coerce it into a string. And it's an optional string, right? Like, the user might not provide anything at all, so that's why we have to put the little question mark at the end. And that means that we probably better provide a default, too. In case they don't provide a customized favorite greeting, we'll give them a fallback, and we'll still say hi. So if we run it again, we should get hi again. But then if we run it with the parameter, if we run it with the property.
So what's your favorite greeting?
What's up?
What's up?
Yeah.
What's up?
Yeah, with 2 S's, definitely. What's up, right? Okay. I think we're done here, yeah?
So, mission accomplished.
Mission accomplished. Okay, Hans?
I think once you get used to that, you never, ever want to go back, right? I mean, immediate builds class path creation when you add a dependency, and you have all the content assist, and you have all the benefits you get when you have excellent IDE integration with a statically typed language. So, and the demo kind of speaks for itself, right? When people are asking why Kotlin, right? And at the end of the day, right, it is the whole package that we get with Kotlin that we are so excited about, right? So it's statically typed at its core, right, from the beginning. And statically typed means it's also much more performant than when you have dynamically typed code, right? And the other part is great IDE support. So those are key reasons why we're moving to Kotlin. So the complexity of Gradle builds is growing everywhere, right? And it was clear to us that we want a statically typed way for writing Gradle builds, right? Because of performance, because of better IDE support. So there are multiple ways to get there. We could have picked Java, right? But that's not what Java is, right? But Kotlin is extremely DSL friendly, right? So we love the Kotlin language. And finally, Kotlin is also used a lot in the Android community as a language to write Android apps, and that's a very important community for Gradle. So they deeply appreciate that they now can use the same language for writing their builds. And finally, this is not just about binaries, right? There are people and organizations behind Gradle and behind Kotlin. In the case of Kotlin, it is a great engineering team that is part of JetBrains, right? And we work very well together, and that is why our progress is so fast. So we want to provide fully production-ready Kotlin support in Q4, and I think it will be a dramatic improvement for the user experience when writing Gradle builds. So I'm very thrilled, with many other advantages like better performance and less mistakes you do, and it's a big improvement. So we are super thrilled. Tomorrow there will be a keynote by anyhow. So about how Kotlin can be used as a DSL language. So from the Kotlin team, I'm very much looking forward to that. So the guys that just gave the demo, they also have a full talk on Kotlin support Friday in the morning. Let's talk about the next feature. One of the holy grails of enterprise builds is to provide an effective way to work with multiple repositories in terms of user experience, in terms of continuous integration. And we want to introduce today a new feature that we call Composite Builds. And this is a corner piece for us to provide outstanding multi-repo support with Gradle. Why don't you show us, Daz?
Be better. So g'day, my name's Daz. I just want to do a quick demo on a new feature that we've been working on. We're calling Composite Builds. We've been working pretty hard with, in partnership with our good friends over at LinkedIn to bring this, with the goal to bring a kind of the power of the convenience of multi-project builds, but with a lot more flexibility to allow for multiple Git repositories, multiple big teams, building lots of different things, sort of allow a bit more flexibility in the way we compose our Gradle builds. So a composite build is basically a way of bringing multiple standalone Gradle builds into another build that we define a composite. So I'm just going to give a bit of a example today. So what I've got is a really simple app, very, very simple. What it does, prints out 20 plus 22. We can have a look at the build script for this. It's a single project build, but it actually relies on a couple of libraries. It relies on the number utils library and the string utils library. So I'm going to just go ahead and we can have a look at this. So I'm going to run the dependencies, see what that looks like. So you can see it's using number utils 1.0, string utils 1.0. It's got a transitive dependency on commons lang. So then I'm going to just try running it's a simple build, runs with an application plugin applied, so I can just do run, and I'll run the main method. And so here we go, it's compiled, run, and it says 20 plus 22 is 440. It's probably not right, so there's a bug somewhere in our software here. So I'm going to let's see what's going on here. So have a look at the main. This all looks pretty good. So maybe there's a problem in my numbers library. So I'm going to have to go out, I'll get the numbers. It's a completely separate Git repository, completely separate project. I'm going to have a look at this, and can anyone see a problem there? Someone's used multiplication instead of addition. Perilous problem there, so I'm going to make a fix. Cool, done, right? I'll go back and run my build again. Should just work, right? Of course not, because that's a binary dependency, right? So what do I have to do now? I can either publish it, change the version, publish it, wait for it to go through CI, update my build script down, to use a new version. That'll work. That's one option. Kind of painful. I could publish to a local repository and consume from that, and that would let me, then I could actually at least not have to tell everyone around. I could try it locally first, but it still means I have to update both my build in my producing project and my consuming project. It's kind of painful. So instead, we'll get to use Composite Build. So I'll, So what I'm going to do is, all I have to do here is go, this is my regular settings.gradle file for a Gradle project, for a single project build. Instead of including a project, I'm just going to include a build. And the build is located as a sibling to this build, and that's what I did. So I've just said include the myutils build. The myutils build is the one I had look over here, this multi-project. It produces with the same coordinates that I was consuming. So its default coordinates are the ones that I'm consuming. So I'm just going to go in here and go, let's see what happens if I run it now. So, gets the right answer. So you'll notice I didn't have to build the other project. What's happening here is you can see the compiled Java task is actually reaching out and has a and executing the tasks in the other build. The string utils task with Java was completely up to date, but number utils had been modified because I obviously made that change. So then I'll just let's have a look at something else. We can see what the dependencies are in here now. This can give us a bit of an idea of what's going on. So Gradle's using dependency substitution here. So we've got the number utils library has been substituted by a project dependency. But that project dependency is a little bit unusual in that it has, you can see the double colon in the middle. It indicates it's a build name followed by a project path. So that's actually saying depend on the artifact produced by that project in another build. And what else can we do with this? There's probably, I guess it'd be really nice if we could just work on all these things at the same time. So I'm going to just try running the idea task. And that should generate a, I will reload, thanks very much. And now you can see I've got a fully configured idea project with both my app and my utils in there. I can navigate between them, so I can go, I want to look at I can navigate between sources. I can even make changes, refactor refactor in both projects. Remember, these are two separate Git repositories, two separate Gradle builds. I've just made the change to both. Now I can go and look at the actual changes, and I can try committing them. And IntelliJ is actually going to allow me to push the changes to two Git repositories in a single action. So it allows us to work seamlessly with multiple repositories and multiple builds. So I'm sure you got lots of questions. Sterling's giving a talk today at 10:45, I think. And I'll be around if anyone wants to ask anything else. Thanks very much.
So, thanks, Des. Yeah, if we would stop with that functionality, this would already be very valuable, but we are far from done with composite builds, right? If you look at it from an architectural perspective, we are creating a strong context boundary when merging builds together. And along this boundary, we can parallelize and we can eventually distribute builds, right? So this is the beginning of something very, very exciting. We already mentioned the talk, 10:45. So let's talk a little bit about Gradle performance. We invested a lot of time and we achieved a lot of improvements when it comes to Gradle performance, and I just want to show you some numbers. Most of the time your compiled scripts are cached, but for example, when you check out a project the first time, it is nice that compiling the scripts it's now 16% faster. We significantly reduced the overhead of unit test execution. So in various areas. So first of all, this is a 100 sub-project build with one test per project. So the key cost you're paying here is the startup of the test JVM that runs the tests. And this time got down from, in this case, from 46 seconds to 33.8 seconds. So it's a massive improvement. And we also improved in the area of test event and reporting. So Gradle is unique amongst build systems that you can hook in listeners from the build into your fork test process. And we have reduced the overhead of that and to generate the reports at the end of the test by something like 20%. So if you have an enterprise build now with 100 sub-projects and 1,000 tests per project, that would save you about 4 minutes test execution time. Right? So very substantial. And yeah, now I would love to have some drum rolls. The Gradle configuration time, thank you, has improved significantly, right, between 2.12 and 2.14. I have 3 numbers here, right? The first is, this is an open source project, 96 sub-projects from a fairly standard build, right? We improved configuration times by a factor of 2. The Gradle build itself is a pretty complex build. We have a very high degree of automation and complex requirements, so configuration time was improved by a factor of 2.5. And finally, this is a real enterprise build from one of our clients, and with all the improvements we did, configuration time got down by a factor of 5, right? So we improved so many things to make configuration faster. Different builds benefit differently from all those improvements, but I have no doubt that for all of your builds out there, the improvements that come with 2.14 and 2.13 there are very significant. Okay, so we talked about how important is it for us to have a statically compiled build logic, right? And here's an example where it's the Spring Dependency Management plugin. We refactored, or we provided a pull request to the Spring team that by refactoring from dynamic plugin code to static plugin code, in some areas, we got the time down it takes for one of our test builds from 46 seconds to 20 seconds to apply that plugin, right? So that is why all the work on Kotlin and having a statically compiled DSL is also so important from a performance perspective. But you, of course, you can do this right now by using statically compiled Groovy or Java. You will get the same performance benefits. So we are far from done with performance, right? In 3.0 milestone 2, we have already changed to a more efficient metadata format for dependencies that improve dependency resolution time. We have a very ambitious roadmap when it comes to performance. We are working intensely on that, so there will be progress with every minor release for the next 12 months. Okay, so one other major new performance feature is our upcoming new cache. Work has started on that. The new cache will come in 2 manifestations as a machine local cache versus our current project local cache and as a distributed cache. And go to Laurent's talk to learn more about that. Let me quickly say something about the new model. So the new Gradle model we talked about a lot at the last summit is working very efficiently, very successfully for our native plugins and the upcoming Swift support. For the Java and the Android plugin, we have realized though that the migration effort for all the enterprise builds that are out there will be very significant if they switch from the current model to everything in the new model. And there's still work to do to make it production ready for Java and for Android. So that is why we have decided to prioritize incremental backporting of features from the new model into the current model for Java and for Android. Eventually they will converge, but that is how we will progress. So it will provide a much smoother transitioning process and enables many of you to benefit much earlier from the good features we have in there. And it allows us to focus better to improve the most important pain points first. Finally, as you have seen, a lot is happening, right? But on top of that, we have some very strategic goals, how we want to evolve the Gradle build tool and its container and microservices as first-class citizens. In the area of dependency management, we want to provide a much better alternative to dynamic versions, snapshots or 1.plus, stuff like this. And variants for dependency management. We have already made a lot of progress with the variants for dependency management, but it's not fully rolled out yet. And JavaScript and Swift support. Okay. The next part of the keynote is about something else. And I want to start with a perspective on our industry, right? From what we see with all our consulting engagements, right? And we basically have an insight from the state-of-the-art Silicon Valley engineering companies to the big financial institutes to smaller companies to engineering companies. What we observe is that the industry is struggling as it has never struggled before in efficiently manufacturing software. Software is becoming more and more complex, and it is a challenge that most organizations are not up to at this point, right? And it's interesting. So many trades have been professionalized, right? Sales, marketing, of course, the classical industries, but the trillion-dollar global software industry has not, right? It's still not, the manufacturing of software is not a professionalized craft. And I started Gradle out of my deep frustration about this fact, right? And the Gradle build tool does help substantially with improving efficiency of the manufacturing of software. And as you have seen, there's a lot more to come, but even the best locally installed build tool is limited in what it can do. If you want to deeply improve your software manufacturing efficiency, you need additional centralized services. And those centralized services are now a foundational part of Gradle. So Gradle just got better. What we call Gradle is from today on the Gradle build tool plus additional cloud services. And the first major service we are offering is called Build Scans. And I want to give you a quick demo on that feature. So what I want to do here, I'm in the Gradle source tree, and I just want to quickly compile all the classes. And what you can see here, -d scan, that tells, this way I tell the build, hey, connect with the Gradle Cloud Service and send this service some interesting data that we can look at later on. So I'm starting this build, and Gradle is compiling. And what you will see at the end of the build is the following. So 97%, 99, here we go. And you see this URL at the end of the build. So I just make this a little bit higher. And when you now go to this URL, you will see what we call a Gradle build scan. Just make this a little bit bigger. And this is extremely valuable metadata that we have collected to make it easier for you to understand what is going on in the build in a very deep way, right? So let's start with performance, right? We have a performance card, and can you read that in the last row? Yeah. Excellent. So what you can see here is, first of all, a breakdown, right? How long the different phases of the build take. And then you can see, okay, how long does the project configuration take per project? You can look at the dependency resolution, and we can see, at project configuration time, no dependencies are resolved. They're all resolved as task execution, as it should be. Thanks, Cedric, for taking out the dependency resolution at configuration time we had in there for a couple of weeks. And you can look at task execution. You can have different ways to order, basically, the task performance and the task profiling data. You have, I need to be smaller. You have very interesting data about the daemon, right? You can see the daemon on my machine is now alive for 1 hour. And this is the second build that was executed with the daemon. And finally, there's some interesting settings and suggestions depending on how you run a build. So in this case, we just sent you a little warning that a development version of Gradle was used, which might be less stable than the final version. But hey, I was using the daemon, parallel execution was enabled, so on that front, there's not much more I can do to make the build faster. We have a very powerful dependency search. So we collect all the dependencies that have been used for that build, and when I want now to search for Guava, you see within milliseconds, you see all the places where the Guava dependency is used, or you can look for other dependencies, and so easily understand what is going on with your dependency graph. What is also extremely helpful is that you have a very good understanding of which plugins are used in a build, right? So you can see and how often they are used, right? So for example, the base plugin is used in all of our sub-projects, but there's also a JSON plugin, interesting. I don't even know where this is used by, and then you can see, it's used by our documentation plugin, right? So for a build master to quickly understand and get this overview, which plugins are applied, this is invaluable information and extremely hard to figure out in any other way. So I show you a couple of other examples for build scans, right? So what is when you have test failure? So we collect all the test execution data, and when tests are failing, right, you can go to the test details, and you can see the output of the test and search an error, so to easily understand what is going on. Another example is when you have a dependency resolution failure, we try to be very smart in terms of presenting you the reason why a build has failed. Much better than we can do this from the command line, right? So in this case, we already show you the important snippet, right? That certain dependencies couldn't be resolved, and where we have looked for those dependencies, etc. Right? What you get in any case, if we go back to the other build scan, we show you the full console output of a build, so nicely formatted and syntax highlighted and colored. So if there's any information in there that you might need, this is also available. And there's a lot more in those build scans, and I think this is an invaluable tool for working with Gradle builds. And so to learn more about this, right after this keynote, Etienne and Luke are presenting the details of our cloud service offering. I think very soon it will be hard to imagine how a build team can work without insights of this quality, right? How can you optimize the build without having hard performance data, right? I mean, we all know that in larger organizations or when you provide something for the outside world, people are saying, my build is slow, right? And you're wondering, yeah, well, I don't know. What can I do? I need more insights to understand why is it slow, right? How can you improve the user experience without understanding what the user experience is? How the users are using your build? What switches they're enabling? How is it used from their local machines? When I go to clients, right, and to the build teams, and I ask them questions like, are they enabling the daemon? Are they running -- parallel? The most common thing I get, well, I don't know, right? We don't know how the developers are using our build. So you can't optimize without understanding that. And how can you teach your developers best practices when you don't know what their practices are? But there is more to build scans than that. There are, I think, other deep aspects that we can improve. The relationship between the build team and the dev team, even in the best organizations, has some friction, right? You might have encountered that. There are two types of behaviors that are particularly damaging, but unfortunately also very common. Developers spreading fear, uncertainty, doubt about the build. The build is so slow. What are those guys doing again, for example, right? And it is easy for developers to do that when they cannot be held accountable for their claims. When their build experience is a secret knowledge they only have. And when you don't have the data to show, well, you added that language that has this terribly slow compiler, right? Or something similar. On the other end of the spectrum, there are build masters completely ignoring truly bad build experiences by the developers, right? And their complaints are not taken seriously, and the developers don't have easy access to data that backs up their claim. They can't easily see whether other developers are having the same issues. That is deeply frustrating. So with our cloud service, we will create accountability for both sides. And this will be very, very healthy and will improve the relationship or will show the path to necessary changes, right? I never forget that meeting I was invited to a couple of years back, 15 people in a room representing a 500 people engineering team, and build masters, engineers, architects, and they were yelling at each other for minutes about what the major reasons are that their build is failing so often, right? It was an interesting experience. They couldn't agree on the major reason and continued as they have done before, very inefficiently. So those days are over with Gradle build scans and Gradle build analytics. So one other important aspect is the build tool is probably one of the most cursed developer tools. Why is that the case? Well, first of all, it tells you very often that something is wrong, and very often it cannot help you very much in figuring out why something is wrong. That is not a combination to make good friends, right? So developers are stuck and frustrated, and with build scans, we can help developers to better understand what is going on, to get unstuck, right? When it comes to test failures, dependency management, there's a lot of features we are planning to make Gradle build scans and the Gradle Cloud Services smarter and smarter, that they can better and better point out to developers where the problem for a certain error is, right? And finally, with build scans, it becomes super simple to efficiently ask for help. Hey, this is the build scan, can you have a look at it? And not, can you run the build in debug mode? Can you check this property file? Can you upload your test reports, etc., right? So finally, the work of the build team is, in my experience, often not fully appreciated in an organization, right? Although the build teams can create tremendous return on investment for an organization, right? In terms of R&D budget savings and time to market. It's heavily affected by the quality of your work. With build scans and build analytics, you will get hard data from our services to show the value that you are creating. And as our offering evolve, making it easy to share the value you are creating will be a first-class function, right, of build receipts. And I think that is very important. You save real hard dollars for an organization, so it's great when you can show that. So I would like to talk a little bit more how we are framing our offerings, right, and the different layers that we have. So For the Gradle build tool, nothing has changed except that we now call it the Gradle build tool instead of just calling it Gradle, right? It's Apache version 2 licensed. You saw the exciting progress. You saw the exciting roadmap. We're investing millions of dollars of R&D into it. It is at the heart of our ambition to change the industry, right? And nothing has changed. What comes now on top is the cloud services. The cloud services are an additional Gradle capability that we have added, and it makes Gradle so much more powerful. So creating, viewing, and sharing build scans is a free service, right? And this service, and it is, we see as a fundamental part of the Gradle ecosystem, right? It's not just some teaser, it's a free service that we make an integral part of Gradle. We will deeply integrate this into the Gradle build tool that you don't need to do any setup for creating build scans, and it makes Gradle even more exciting platform. And finally, I'm very excited to present you the Gradle Enterprise subscription offering. So Gradle Enterprise is an on-premises version of our cloud services with additional features. It is available today, and Luke will demo you the product right now.
Thank you, Hans. So what we're looking at here is Hans mentioned that Gradle Enterprise is the on-premises version of what we saw before. So this is something that you can install today. As Hans said, we are offering it today. Come and talk to us about it if you like what you see here and would like to get it going in your enterprise. So what we've got here is the first Gradle Enterprise exclusive feature. And what I'm actually seeing here is a list of all the build scans that have been pumped into the system. So here I can see the user that created this, whether the build passed or not, the name of the root project, what was run, and some other metadata. The important thing to think about here is that this isn't just my CI builds. These are all my builds, all developers, all machines across the whole enterprise, all projects. That's a level of information you haven't had before. So I can come in the morning and see what happened in the previous day. See, okay, well, tell me which builds by Tom failed? No. What have you been doing, Tom? No, I would go and help him with his problem then, of course. So I can search by user, whether things fail or not, for particular projects. I can get very specific, looking at different time ranges, all this kind of stuff that you would expect. I can see what ran on which machine. Perhaps I want to see all the builds from a particular CI machine or a particular workstation, that kind of thing there. Of course, I can clear this. Of course, I can go and sort things. I can say, well, show me the slowest builds.
Do we have it for Gradle itself?
That ran yesterday. Slowest pass builds, fast fail builds, those kind of things. How many times has someone gone and looked at this build scan? See, that's interesting. Something's going on with this particular build. Maybe developers or build engineers are collaborating around this. It's been viewed 6 times or however many. So I think this is a really great capability to have and to surface a level of information about how your projects are going and how your builds are actually doing in the wild, right? How are your developers running it? What's actually going on? And of course, from here, I can click through and see the actual build scan itself. So this is something that, like I said, is available today. And it's a very, very simple application to get going. So installing this is about 3 commands. It's a fully containerized solution. Any kind of modern Linux system will do. We'll set you up and our application starts running, manages all of this stuff happening in the background. Here's a bunch of containers running at different bits of the software. You can see how CPU is doing, how is memory going, all these kind of things. So just the general maintenance is there. A very important aspect of this is just the beginning. As Hans said, we have very elaborate and ambitious plans on what we're going to be delivering over the coming months in terms of features. And if you install Enterprise, getting those new features is as simple as, if I'm connected to the network, yeah. So it's actually installing a new update, a new version of Enterprise as we push out new features is as simple as coming into this admin console that you also get with it. Clicking this button, it will download the new updates from our servers, install them, and away you go. So as we're rolling out new features over the coming months and years, you'll be able to very easily get those going. And it takes care of a bunch of other things for you. Of course, configuring all aspects of the installation is very simple. SSL configuration, where you want to store all this stuff, You can go and have a look at the logs and whatnot. If you want to see when was the version updated, who deployed new updates of this software, that's all in there. And importantly, if for some reason you're having some trouble with your installation, something's not quite working, there's a feature here where you can download the support bundle, which is effectively a snapshot of your installation. Send that to us, we can help you reconfigure it, get it going again. So really easy to operate, really easy to administer and maintain. Provides backups, all that kind of stuff. Moving it across machines, scaling it up, down is also very simple. So this is something that we're offering today. So if you're interested in this, please come talk to us. We'll be outside the main lobby area, and we'd love to show you in more detail. Thank you.
Thank you very much. Yeah, so I think we are one other thing that comes with the Gradle Enterprise subscription is also our excellent Gradle open source support, right? That gives you access to our engineering team when you have questions and issues around the Gradle build tool. And we will roll out feature after feature. We have a very active, capable, and growing cloud services team. So our feature focuses on 3 areas, right? One is build infrastructure efficiency. The other is developer efficiency, especially around reducing debugging time. And finally, provide deep organizational insights, for example, around collaboration patterns between teams. So yeah, and we have our booth out there in the office hours. When you have booked some office hours with us, we're more than happy to go into more detail about that. For us, it's almost a new era. It's something we wanted to do for years, and so I'm super thrilled that we have now finally have finished the work and provide this to the world. It will be a completely new phase, I think, for build teams and organizations. How you can improve the build, how you can collaborate with people on the build, and so I'm super excited. Yeah, thank you for your patience and for giving me your valuable break. Sorry again for the fire alarm, and enjoy the conference. This one.